In this recording, we're going to learn how to solve quadratic inequalities. And it's really not so bad if you know how to factor, and you guys are getting good at factoring. We're going to introduce it by looking at a graph. So we have a graph here of the quadratic y equals x squared plus 6x plus 8. And you can see it's practically the same thing as this quadratic inequality up here. The inequality says 0 is less than or equal to this expression. I'd prefer to just rewrite it. So I've got x squared plus 6x plus 8 is greater than or equal to 0. Again, it's still pointing to the 0, so it's the same equivalence. Cool. So let's have a look at this graph. And let's say, okay, I basically replaced the y down here with a 0 up here. So in what cases, for what part of the graph, is the graph greater than or equal to 0? Where are the y values that are greater than or equal to 0? And hopefully you'd say, wait a second, it's here, and including that point, greater than or equal to, and it's all this up here, all that part. Or it could be all this part over here. Notice I'm using a solid dot because it's greater than or equal to. So it's all this part over here, all those numbers, or all these numbers satisfy the inequality. So any of those x values that I would sub in that are in this blue area would make the inequality true. And so now I just need to write it as a graph, a number line graph. So I make my number line. Key numbers on the number line are the x-intercepts, -4 and -2. Okay, again, solid dot, because it's greater than or equal to. There's a line under here. It means it's equal to. And the graph is less than or equal to -4. And it is greater than or equal to -2. Just sort of make a one-dimensional graph here and a number line out of a two-dimensional xy axis here. All right? Then we just write they express the answer in interval notation. So it's this interval here starts with an arrow head, and it's pointing left, so we know that's going down towards -infinity. And it stops at -4. That's where the interval ends. We bracket it because it's filled in. Union. We have a different interval here that starts at -2, and, well, it doesn't end. It has an arrowhead, so that means we're going to say its maximum is infinity. Circle that. Done. Okay. All right, now let's look at a different example, very similar. This one starts out 0 is greater than, as opposed to 0 is less than or equal to. Again, I'm going to rewrite it so that the algebraic expression, is over on the left side. I just find it easier to read x squared plus 6x plus 8 is less than 0. Okay? So again, we're comparing it to the graph where we replaced y with 0. So I want to know where the y values of this graph, okay, are less than 0. So, well, anywhere in here, the y values are less than 0, right? Anywhere in there. And you gotta think about the endpoints here. These are open dots because it's less than. It's not less than or equal to. It's a strict inequality here. Okay? So anywhere in here, those x values are going to give us a y value that's less than 0. So what are those? Well, they start at -4, basically just converting, again, our two-dimensional xy graph into a one-dimensional graph, because we're really just interested in x values up here in the inequality. Open dot, because it's not equal to, and then it's just the interval in between here. So it's pretty easy to express that interval because it's just one interval between -4 and -2 without including the endpoints. All right, so that seems easy enough if we have a graph and the endpoints are integers, which they will be for our quadratic inequalities, but we won't always have a graph, and nor do we need one because we know how to factor. Okay, so let's look at one where we're going to solve this algebraically. So anytime I see a quadratic inequality like this, the first thing I'm going to do is rewrite this as an equation. Okay, I don't like the quadratic inequality. I want to make it into a quadratic equation. So I'm going to leave it exactly the same, except I just changed the inequality symbol into an equation. Now I just need to solve this. So play the video once you have solved this quadratic equation. Alright, so hopefully you realize we have to get a 0 on one side. I always like to keep the x squared positive. So I'm going to go x squared minus 5x minus 6 to get a 0 on one side. I'm going to do some factoring here. Okay, so x and x are going to multiply to be x squared. Now I need two numbers. I need two numbers that add up to negative 5 and multiply to be negative 6. Looks like negative 6 plus 1, right? Of course, we know that means x equals 6 and x equals negative 1. Cool. That, however, is not the answer to the quadratic inequality. If this were the equation, we'd circle those answers, we'd be done. But all that means is, just like with our graph, we have found the endpoints. We have found, if you remember from before, we have found the places on the x-axis, the places where it would make it equal to 0, but we either have to go in between them or we have to go beyond them, depending on the symbol. So back to the one we had, we're going to put those numbers on negative 1 and 6, filled in dot because it's equal to, and now we need a test point. I like to test 0, so test x equals 0. If I sub in 0 here, I get 0 on the left. If I sub in 0 here, I get 6 on the right. So is 0 greater than or equal to 6? No, that did not work. So that means no number in between negative 1 and 6 will work. So you shade out, and then you just need to write it in interval notation. And so this to me looks like a negative infinity up to negative 1, bracket, union, 6 to infinity. There's our solution. Okay, so now what we're going to do is we're going to write out the steps, and you can just pause this to write out your steps. Okay, so the first step was we rewrote it as an equation. Secondly, we solved the equation, this over here, to get the critical values of 6 and negative 1. Remember, those weren't the solutions, right? And I just sort of broke it down here. Write this if you think it's helpful. Get 0 on one side, and then factor, right? What do we do next? Well, we plotted the critical values, the negative 1 and the 6, on the number line and used a test point to determine the shading. Okay? Lastly, once we had that graph, it was pretty easy for us to just write the solution in interval notation. Thanks for watching.